So today we have day 4 of 5 with our scientific method. Today we're going to learn about how scientists collect and organize data. What do scientists do during experiments? They collect data. Data collection? Data generally refers to the results of trials or tests completed during experiments. A data table is an important initial stage in making sense of the information you will collect while doing an experiment. How can we organize this information? A data table makes organizing data easier to read and study. On the bottom over here, we have an example of a data table that can be used during an experiment, where the independent variable are the rows, and we have the dependent variable as the trials. Organizing data and data tables. Identify the variables in the experiment. Set up tables using appropriate labels and unit of measurements. In most cases, the independent variable, which is the variable that you purposely change, is in the left column, and the dependent variable, which is the one you measure with the different trials, in the next columns. And the derived or calculated column, often average, is on the far right. Data tables. The independent variable is usually written on the left column, and the dependent variable is always on the right. This is a graph. Why do scientists utilize graphs? A carefully constructed graph can provide us with a large amount of information quickly. It also shows us to carefully analyze our results from an experiment. Different types of graphs. There's a line graph. What is this line graph telling us? On a line graph there are labels. As you can see on the bottom it says the year, goes from 0 to 2200. On the side you could read world population in billions of people. So what this line graph is telling us is that as the years go forward, the population increases exponentially. There's a pie graph. This one is a circle with different slices, much like a pie. And this one is telling the different ethnicities in a certain place. There's a bar graph, which includes bars, where the bottom is the dependent, the side is the independent. Let's graph the results of our experiment. We will be making a bar graph from our results. We will graph the average heart rate for the control group and the experimental group, the y-axis and the x-axis. Results for constructing graphs. Rule 1. The dependent variable is always plotted on the vertical y-axis. Rule 2. The independent variable is usually plotted on the horizontal x-axis. Rule 3. The scale and spacing between the numbers on the both axes must be in equally spaced increments. Rule 4. Label each axis, the units, and title of the graph. Our graph here, the side is the dependent variable, which is the y-axis. It would be beats per minute. The bottom, the x-axis, which is the independent variable, would be number of jumping jacks. And as we fill out the bar graph, you'd see the blue is the control group and the yellow is the experimental group. And the title, the effects of exercise on heart rate. What are our results? Our results indicate that the heart rate increased after students performed 30 jumping jacks. And our conclusion, was the hypothesis supported or rejected? This experiment supported our hypothesis. Physical exercise, jumping jacks, increases a person's heart rate. And with that, that is the conclusion of our video today, and I hope you see you next time.